Raquel.
What's our next area of study today?
I'm doing real good right now.
We should definitely talk about the effects of e-cigarette vapor on one's alveoli. Of course, I mean, we live in Utah, and so
Hey,
pollution.
fuck my alveoli.
Tell us more about irrational numbers.
Yes. I want to know more about irrational numbers because I feel like rationally that doesn't make sense.
So irrational numbers are great because they make up most of the number line. In fact, if you randomly choose a number from the number line, the probability of choosing a rational number is 0 because of the different levels of infinity of both of the numbers. So, rational numbers are countably infinite, which is the kind of infinity that is 1, 2, 3, 4, 5, 6, off until infinity, right? Yeah.
And beyond!
Huzzah! And irrational numbers. There's a great proof that I think it was. I'm gonna fucking butcher this name. Georg Cantor. Georg Cantor. I'm just gonna anglicize it.
Yeah, George.
Georg Cantor. Good old George. He had the diagonal number proof that lets you take one set of things and map it to another set of things. So if you take the countable numbers, 1, 2, 3, 4, 5, you can one-to-one match them with rational numbers, like 1 divided by 2, 1 divided by 3, 1 divided by 4, etc. off to countable infinity. 2 divided by 1, 2 divided by 2, 2 divided by 3, 2 divided by 4, off to countable infinity again. In a very clever way that I'm too drunk to explain right now. But you can construct a proof that in another very clever way constructs irrational numbers that cannot be described by the ratio between two rational numbers, in a way that you can map every single one of the countably infinite numbers to these numbers and then come up with an extra number. And so
Can you
what that
explain
means,
that? Because I'm just thinking like 1.3892. I don't understand.
insert link to the diagonal proof by Georg Cantor here. Because I can't right now. But he was very clever about it.
To be fair, I can't explain the diagonal proof even when I'm sick.
Let me try. So it's you list horizontally all of the irrational numbers, and then you diagonally go through the columns and you say, you have listed all of the irrational numbers here. I'm going to take this one, I'm going to add 1 to this column, being the 10th decimal point. I'm going to add 1 to this column, being the 100th decimal point. I'm going to add 1 to this one, being the 1000th decimal point, etc. And the result of that is that you have a number that you now cannot correlate to the countably infinite number of the countable numbers, the 1, 2, 3, 4, 5, off to infinity. And so because you have a countably infinite number of the integers, the rational numbers, because that's a one-to-one mapping between those two with his clever proof, which I cannot repeat right now. But it's one-to-one, so it's fine. But so you cannot take the countably infinite set of the integers and one-to-one map them with the uncountably infinite set of the irrational numbers because of this proof. So, like, the proof is literally, you're left with at least one extra after you have exhausted infinity of the countable numbers.
Who
which
thinks
means
of
it's
this shit
uncountable
and
infinity.
why?
Say that again.
Who comes up with this shit and why?
Georg Cantor. He went crazy and killed himself.
To be fair, it
Literally
was
true.
in
That
vogue for
happened.
mathematicians to commit suicide in that time.
Yeah.
Especially